Welcome to day 3 of my daily Leetcode daily challenge. Let's jump into it. Today's problem is 498 diagonal traverse. Let's have a read. So given an n by n matrix, let me get my comment ready. Right. An n by n matrix, return an array of all the elements of the array in a diagonal order. Okay. Um, all right. So we do the top right corner, and then we go one across, down this diagonal, down. Okay, so there's no obvious pattern I can see. I remember from I think it's the n queens problem. When you want to check the diagonal, these numbers are equal the same. So like if let me just annotate on this. Um, right, so this would be 0, comma, 0. This would be 0, 1. This is 1, 0. So I believe it's okay. Let me just check the rest. So this is 0, 2. This is 1, 1. And this is 2, 0. This is 1, 2, and 2, 1, and so on. So as you can see, the indices, the coordinates add up to 0 here, up to 1 on this diagonal, 2 on this diagonal, 3 on this diagonal. So I'm thinking maybe we can use that. Um, but then we also need to get the ordering right. So we go up the first diagonal, and that's always first. 10 off annotation. So first will always be 0, 0. Down, next diagonal, and then up. Okay, so what else can let me get rid of all this. Okay. Equals mat length, equals mat eye length, turn 4, turn 4. Okay, and they're both at least 1, so we'll have at least 1. Edge case equals n equals 1. And 0. Awesome. Bringing out that edge cases. Mm, 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 mm. So one thing that I can see is here, after this diagonal, we go to the right. Then after this diagonal, we go down. After this diagonal, we go down. After this diagonal, we go right again. So how do we figure out the first thing I need? Okay, let's do just a little example. We had let's imagine we had sorry. Then we have 1, 2, 3. Then 1, and 2. So let's just change color. So first one will go here, then next one will go right, and this one will go down, and this one will go right, this one will go right, this one will go down. It doesn't seem like there's any clear pattern. What I want to think is, like intuitively, how can we get it? Mm, so, okay, start with this one, and go to the right, and then let's write these in again. 0, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0. When we go here, then we know we have to go back. So we subtract 1 from the um so it looks like it kind of depends which edge we end up at. Right, but we subtract 1 from oh sorry, we add 1 to the row and subtract 1 from the column. And then since our column is 0, we know we can't go any further. So what we do is we go. How do we know whether to go down or left? That's the question. So 1. Okay, because the column is 0, we know we can't go left, so we go down. And then we're at 2, 0. Just to go down, you add 1 just to the column, and then we go -1 plus 1, -1 plus 1, and then we are at the second column, so we know we need to go down. So then we go um, +1 plus 0 to go down because we're looking at what has changed. So there's two cases, one where we're going up and one where we're going down, right? So for the up case, up, I can just type this out. I don't know why I'm doing this. Okay, up case, we when we're going up, we subtract 1 minus 1 and plus 1. We're going across. Then down case, +1 because we're going down, and -1 because we're going backwards. Right, so these are the two cases that we have, and we start in the up case, then case down case, right. And then, so when we're in the up case, if we hit the top edge, so what about when 0, 2 here, when we hit the right and the top edge? Oh, because we want to go down or right. Okay, so top edge. If we hit the top edge, we need to either go right or down. We need We go right or down. Mhm. How do we know here to go right and here to go down? Because in this case, we are not on the right most edge, go down. We are, sorry, if we are not at the right most edge, go right. And if we are at the right most edge, we can go. And then for the down case, how would this apply, right? So, uh, okay, so actually, you know what, here. If we're at the rightmost edge, we have to go down. And if we're at the top edge, if we hit, forget what I said here. We're at rightmost edge, go down. If we hit top edge, so if we're right and top, it'll go down. And if we're just at the top, we go right. If we hit top edge, we go right. Because we always prefer to go right. It's only at the end when we hit the rightmost edge, then we go down. The down case is the same. If we're at the leftmost edge, go down. Um, will this all work? Okay, let me confirm. So if there was another square here, for example, let me draw another square here, we would go down here. Then we'd have to go, because we've hit the leftmost edge. Oh, here is a case where we're at the leftmost edge, but we need to go right. So on the right, hmm, at the leftmost edge, only when we're at the rightmost edge. We go down. But here it seems to be the other way. It's first and foremost, if we're at the bottom edge, we go right. Edge, down. Right. We're going right. We want to go as far right as we can. Mm. So how'd this go? We go here, there. Be here. Go down. Go down. Hmm. Sorry. Excuse me. Just trying to understand the logic of why. Mm, 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 mm. Yeah, so we would end up here. Then we'd go right. From here, we want to go down or right. Here, we prefer to go only for the rightmost edge. We have to go down. And here, only for the leftmost edge. Have to go right. Um, all right. Let me try to think about this. Okay. Why must we go right? Yeah, up, up, up. And then we go right. If we can go right, we always prefer to go right. Up edge. Because we're already traveling downwards. So after reaching the bottom. Okay, okay. Because we're already traveling downwards, us reaching the bottom means we can't go any further down. So if we hit the bottom, whereas if we're going up, we go all the way up and then we can go down. All right, let me just try and implement this. Mm. We're at the rightmost edge. We always have to go down. We can't go right. And if we're at the leftmost edge, if we're at the leftmost edge, we also, hmm, because we're already going down, so us being at the bottom means we can't go any further down. So we have to go right first. Okay, okay, okay. So, um, ooh, mm, Int should also initialize m and n. Int m equal m or n doesn't equal m. Sorry, c doesn't equal m. Okay. C. Okay. So element in, and then if up, if we're going up, um, if we one. So first we want to check the columns if c equals n this one. Uh, go down. That means r plus plus if is it else or is it else if r equals n minus one. Um, uh, so if r is m minus one, means we have to go. Oh, sorry, r equals 0. If else if we the top go right, so that means we go c uh, L, and else yeah as well. R r minus minus c plus plus L. Now we need to first check if we hit the bottom edge, so that means the row equals m minus 1. And if we hit the bottom edge, we go right. So that means c plus plus equals true. L if So now we're checking if we're at the leftmost edge, so C equals 0. Uh, if we're at the leftmost edge, and we're not at the bottom, so that means C equals 0, that means we go down. Yeah, R plus plus, else R plus plus, and C minus minus. And finally, we will add, um, let's do, uh, hmm, size type 2, an integer, match 0. What size? Should if let's check all my ifs and else's. Put it in two brackets as well. C equals 0. Oh, what's happening here? 1, 2, 4, down, 7. Oh, sorry. Let's try that. See, does it work? Okay, that was not my best work, definitely, but we got there in the end. Um, through a bit of intuition, that's not ideal. I should be able to understand why that worked. So I will do that in my own time, but thank you for tuning in, and I will see you guys tomorrow.